Hello, and welcome back to Venom ASMR. Today we're doing some epic chemistry study. Just a little tidbit of what I've been writing. So let's get straight into it. Avogadro's constant, which is 6.022 times 10 to the power of 23, is the amount of atoms in 1 mole of hydrogen or most other substances, and is used to find out how many atoms there are in a given concentration of a substance. You can do this by using the equation number of particles equals Avogadro's constant multiplied by the moles. This in turn can be used to find the MR or mass of the substance using the equation moles equals mass over MR. Ionic equations are, well, these can be used in any reaction involving ions that happen in a solution. So what you want to do to get an ionic equation is, number 1, write out the full balanced equation, leave nothing out. Number 2, split any dissolved ionic species into ions. So that basically means remove anything that isn't an ion and just sort of doesn't do anything. And number 3 is remove any spectator ions. So if there's any ions there that just aren't really reacting with anything, you just get rid of them because they're a bit useless. And here are the most notable ions to remember are H+, NO-, which is a nitrate ion, Na+, which is sodium plus, and OH-, which is a hydroxide ion. Next up is atom economy, and atom economy is basically used to determine how useful a reaction is in terms of how many atoms you actually get out of it. And you can do this by using the equation atom economy equals total MR of useful product, which is the product that you want to get out of the reaction, over MR of all of the reactants, which is everything on the left-hand side of the equation, and then multiply that whole little shindig by 100. And this is very similar to percentage yield, which is how much of a substance is obtained in a reaction. It might not be useful, it's just how much of something out of 100 is obtained in a reaction. And in a very similar equation, it is percentage yield equals experimental yield, which is like the mass of what you get out of the what's called the reaction over the theoretical yield, which is how much you expect it to get out of it, and multiplied by 100. Next up is the difference in temperature and heat. Now they may seem the exact same, but in terms of chemistry they are very different. Temperature is related to the average kinetic energy of particles in an entire system, and it is independent of the number of particles. And heat is a measure of the total energy of all the particles present in a given amount of substance, and it is very highly dependent on the number of particles. And this in turn can be used to calculate enthalpy, which is very useful in energetics and kinetics in reactions. And enthalpy, or delta H, which is a little triangle next to a H, is the change in heat energy at a constant pressure. And you calculate this by using Q equals M times C times delta T. Now the Q is the enthalpy change, which is not the enthalpy of the action, but just the change in enthalpy. It doesn't give you the actual enthalpy itself. The M is the mass of the substance being heated. C is the specific heat capacity, which is basically how much energy is required to heat a substance by 1 degree Celsius. And delta T is the change in temperature, which is rather self-explanatory. And then once you have Q, or enthalpy change, you can then use delta H, which is the actual enthalpy of the reaction, equals enthalpy change over moles. And now for a little bit on exothermic and endothermic reactions. And reactions that make bonds are exothermic, and reactions that break bonds are endothermic. And a little acronym you can use to remember this is BendoMex. Bendo referring to the B in bendo means break, and endo means endothermic. And the mex, annex mex, the N is short for make, and the X is short for exothermic. And that's some chemistry stuff for you, just a tidbit of chemistry. And as always, I would like to calculate the enthalpy reaction of the Venom, please. Thank you.